So let's introduce Dr. Keryn Johnson from New Zealand. He is the CEO and founder of Quantum Technologies Limited. And we're here today to talk about his theory of quantum biology. And I'm going to put a few questions to him. And let him explain in his own words what he is doing and how it is revolutionary in both quantum terms and spiritual terms. Okay, Keryn. Let's begin with the question of light.
What is light?
Okay.
Yeah.
We have the theory of relativity. For Einstein, space and time are defined by light. And quantum theory goes beyond that into the uncertainty principle. Now, you introduced the singularity model, and I'll let you take it from there. Okay. What is light and what is the singularity model?
Okay, so for me as a biologist, light is not something that I learned about. It was obviously, it's a very intuitive thing for a human being to see. And understanding the human anatomy of the human retina with the rods and cones pointed inward, having an inverted retina, means that we can see our dreams at night with our eyes closed. So light is generated within the mind. Okay, so if we start with that as the position of what we're seeing, at least in some respects, and the anatomy of our biology is the generation of light. Okay, so that's a starting point. For me, I went to Einstein, and you know, the mass equivalent equation that Einstein produced in 1905, the E equals mc squared, probably his most famous equation that everybody knows. And everybody says that E is energy, m is mass, and c is the speed of light squared. Okay, so I because we're looking in and not out, from that point of view, I rearranged Einstein's equation, and you can rearrange it into different forms. One form that I particularly like is the c squared equals E divided by m. So light squared equals the energy divided by what most people would say, mass. And I took, I guess, the leap of faith, one would say, and rather than seeing m as mass, I said, well, m is magnetism, not mass. Okay, so here we have E divided by m, or rise over run. Okay, so on a cross, a mathematical cross, where the y-axis is E and negative E, and the x-axis is m or negative m, we can put, or we can understand the right-hand rule of electromagnetism, or E divided by m. So here I've kind of looked at Einstein's equation differently to look at it as light squared equals that relationship between E divided by m. I put that on a mathematical cross to see E, m, negative m, in order to see the balance between those two opposite sides, the E divided by M, and down in the bottom left-hand corner of that mathematical cross, it's negative E divided by negative M. And obviously the other two quadrants as well provide a contextual framework of 4 areas. And I looked at that and I went, well, I don't think mass and M really go together at all. I think it is electromagnetism. So that whole right-hand rule of electromagnetism, E divided by M, and seeing that division as the concept of being at 90 degrees to each other. So in a sense, I was looking at the fundamental geometry of that equation in terms of the geometry of light or electromagnetism. And C squared, well, we got C coming out one side and we have C coming out the other side. So the point at the cross is, in essence, the singularity, where every action has an equal and opposite reaction. And that conceptual framework of the balance of opposites, of a plus and a minus, of that dualistic perspective of an electron and a positron. And so I was looking at the mirrored symmetry within my own biology to try to understand where that was originating from foundationally, right? If we have this model for light, and light being very foundational to the universe in the cosmological understanding of Einstein's general theory of relativity, then we can explore the relationship within atoms and the electromagnetic field within atoms through the point of the singularity. So there are very kind of interesting, I guess, features to atoms that we're taught as biologists, as a biochemist. You know, protons, electrons, and neutrons, and that was the model that I was taught. But in this this symmetry, supersymmetry, inverted symmetry model that I've been developing, the singularity acts as the reference point, the 0, 0, 0. So that central point within the atom is like a mirror that reflects to the singularity that was present 13.8 billion years ago. And there's mathematical techniques that you can use to use the Planck scale, which is the smallest scale that physics has, 1.6 times 10 to the negative 35 of a meter. And because the rise overrun that kind of inverted balance of opposites, 1 over the Planck scale gives 6.25 times 10 to the plus 34 meters. So all of a sudden, there are these balanced extremes within the universe itself. And my supersymmetry inversion model allows one to explore what the universe looked like 13.8 billion years ago by looking through the window, so to speak, of the Planck length through inversion, and then looking at the speed of light times the number of seconds that have existed in the universe, 4.355 plus 10 to the 17. And you'll get a number around e to the 26, right? So you get some big numbers. And what you find is that there's this mismatch, right? There's a mismatch between this Planck scale inversion to e to the 34 and the speed of light times the amount of time that has been in the universe. So light couldn't have traveled that distance. And so you're kind of stuck in this paradigm, well, if light's the fastest thing in the universe, then how could that be where it is? And so there was this idea of the inflationary epoch and faster than light expansion of the universe. So the singularity model allows you to understand expansion. Okay, so by seeing the difference between those numbers, you can understand the original geometry of the universe. There was something there to begin with, but we can't see it. And the reason why we can't see it is because it's all at the same energy level.
So, okay, let me stop you there for a second, because what you're explaining and is quite fascinating. So you're contradicting the model put forward by the British physicist who claims that the universe is imploding, Stephen Hawking. In your model, the universe is expanding.
It is doing both.
Is doing both.
Yeah, right. Simultaneously to maintain the balance of opposites.
Right. We have talked about this, yes, and we have compared it to the yin-yang theory.
Indeed. So, yes, in a sense, the original universe, and I call it the Hebek singularity, is in my model, in the supersymmetry inversion model, is a helium Bose-Einstein condensate near absolute zero, which is super cool, a superfluid, and is a sphere with a diameter of c squared. Okay, the idea of c squared equals E divided by M. So the dimensions of c squared, or the radius of c, provides a fundamental parameter of the universe, but it also, when you multiply c by the speed of, so the speed of light by the number of seconds in the universe, you don't get the right number, right? You get this number that's slightly off. And so if you go back to the idea of this helium Bose-Einstein condensate, there have been helium Bose-Einstein condensates made by physicists. And what they've found is that there's some, I guess, specific numbers in the distance between each fundamental particle within the condensate. So what happens is that when the atoms are cooled, they become, in a sense, like a flock of birds flying together cohesively. So they become, in a sense, one atom, one super atom, right? So the idea is that there's this one quantum superfluid to begin with in the universe that's cold, that emits alpha particles. The distance between the fundamental particles is 4e to the negative 14 meters. And when you look at the binding kinetics, based on that number, you do the calculations to the kilojoules per mole as a velocity, then you have a 9.97 times faster than the speed of light, giving an inflationary phase of the universe, which is still expanding today as the dark energy.
Right.
So alpha particles in the supersymmetry model are dark energy, and that's the expansion. But as the velocity is slowing down, as it's expanding, it's decaying to create mirrored pairs of fundamental particles, positron-electron pairs, which produce...
Now, dark matter in your model comprises the greater part of the universe.
No, the dark energy is currently, it started at 75% and now is at 68%. The dark matter was 25% to begin with and has increased to 27%, and matter at 5%.
Okay.
The other numbers. So
right. What is the
matter,
difference? Yeah. Mm-hmm.
Yeah. Okay. So the helium Bose-Einstein condensate has 16 fundamental particles per atom. Why 16?
Mm-hmm.
We can get to the quark charge calculation correction to give charge parity with positron-electron pairs in a minute. But 12 go out as alpha particles, 4 per atom go in. So the 4 that going in are traveling at the square root speed of the external velocity, of the outward velocity. From that perspective, they've traveled for 13.8 billion years to get down to the Planck scale of 1.6 e to the negative 35 of a meter. So that's relevant today, not just after the concept of the Big Bang. So the supersymmetry inversion model, in a sense, turns everything upside down in order to see what happens today rather than what happened supposedly 13.8 billion years ago. So as it's traveling closer and closer and closer and closer together, the 4 particles have got down, in a sense, to the singularity that we consider the singularity of no space, no time, no mass, no charge. 2 electrons, 2 positrons, overall 0 charge collectively. There's a decay of dark matter. So that's a dark matter particle down at the Planck scale. There's a dark matter particle that decays into antihydrogen, which is 1 neutron and 1 positron. And then the alpha particles decaying into a helium-3 So that contains 2 protons, 1 neutron, 2 electrons, and 1 positron. So what probably will raise some people's attention is I'm including positrons into the atomic structure. And that is really the correction of the baryonic asymmetry issue that is currently plaguing the standard model of physics. So if we go and look at the quark charges for neutrons and protons within atoms and the standard model, the proton contains 3 quarks, 2 up, 1 down. The neutron contains 3 quarks, 2 down, 1 up. In the standard model, if it's pointed up, it's plus 2/3. If it's pointed down, it's negative 1/3. And they're added together to get plus 1 charge for the proton, 0 charge for the neutron. In the supersymmetry model, that's different. We're using -1 if it's pointed up and +1 if it's pointed down. So in a sense, it's kind of opposite to what you'd expect. If you're going up, you're positive, and going down, you're negative. No, and the balance of opposites that is obtained through supersymmetry, it's like yin yang, like you said, where up's negative and down's positive, and we multiply them. So -1 times +1 times -1 is +1 for a proton, and +1 times -1 times +1 is -1 for a neutron. So here we have a model where neutrons are -1, but in the standard model they're 0. So I introduce the positron in order to counterbalance the charge within the neutron to get an overall charge of 0. And that gives an explanation why the neutron is bigger than the proton. And that gives a reason why there's a mirrored symmetry through the singularity of neutron and proton within the nucleus, and outside of the nucleus, the electron and the positron. So it's a logical model that doesn't require measurement. So it's got a non-interactive model at the point of the equilibrium. And the reason why I developed this model was because I was working on a product that has single atoms housed in a sense, a Faraday cage of an aromatic ring. And those single atoms behave very strangely. In a sense, they're doing isotope physics. They're putting hydrogen into the atom, become unstable, the atom decays, releasing the energy. And so there's this process of isotope physics operating in biology that I wanted to be able to explore. But when you measure them, you disturb them. So I had to create a logic-based model of non-interaction to be able to understand the properties of them, where every action has an equal and opposite reaction. So from that balance perspective through the singularity acts like a lens of a pinhole camera and inverts the structure, right? It turns it from this side up to that side, right? So in a sense, it in the atom, as the electron in K plus or electron capture goes through the singularity, it's inverted to become the positron. But if it's retained within the atomic structure of the nucleus, it's negative there, it becomes positive here in the nucleus through that inversion event. And if it's positive, then it's a down quark. So the down quark plus becomes the electron minus. And the opposite is true for the positron being plus becomes the negative up quark. So there's this kind of inversion system happening through the singularity that flips everything upside down, which confuses the heck out of the kind of model, right? It's like, well, this can be that. And this kind of beta decay, beta plus, beta minus provides a conceptual framework of the correction of the quarks, so that balance of zero is maintained within the atomic structure of the nucleus. And there's this exchange of positron-electron pairing with the quarks flipping in order to give the atom the state of balance within it. And so the isotopes are actually this unstable state where there's charge within the nucleus and there's the mismatch, and they correct through the beta decay process, but they can also correct through alpha particle or loss of a neutron. So the model that I'm developing, the supersymmetry inversion model, really incorporates the understanding of the unstable atoms into biology. And the reason why I've done that is that because it really kind of gives a fundamental reason why time occurs, right? If we think these half-lives of unstable atoms have a very beautiful synchronous timing to them, and when they're housed in that aromatic ring as a Faraday cage, they're isolated from the environment. They're a quantum competent system that's connected to our neurotransmitters. So I'm saying, really, I've discovered a process where hydrogen is quantum tunneling into single atoms housed in aromatic rings, and I've developed a product from Manuka honey that uses the system, but it mirrors the natural systems that are going on within the human body, within the human mind, at that unconscious part of the mind outside of the neuron, which is the idea of, well, that's where the light is originating from, the decay of the atom and from the isotope. Hadron jets being released as it's decaying, giving the light which we're seeing in the dream with our inverted retina pointed inward, seeing at night with our eyes closed. So the model gives a framework in which to understand unstable atoms, apply them biologically to understanding time and the perception of time, and in alignment with the human anatomy of the retina pointed inward, giving a way of understanding how light can be generated from the electromagnetic fields within the structure of atoms, producing the image that we perceive to be the external physical world, but is actually the manifestation of the physics happening in the unconscious part of the mind to give us the vision that we see. So it's a model that connects, I guess, the cosmological understanding of how the universe operates from the helium Bose-Einstein condensate, the singularity to begin with, the outward generation of dark energy, the inward generation of dark matter, and then that concept of those things and those ratios that are correct to see that positrons are actually present within atoms, and then go back to single atom systems of positron electron pairs like yin yang, but it also has the neutron connected to the positron through quantum tunneling and entanglement, and the proton connected to the electron through quantum tunneling and entanglement, and the nucleus -1 neutron, +1 proton to give stability within the nucleus. And we have 4 fundamental particles and s orbitals. So if we go back to the original c² = E divided by m on that mathematical cross, and the 4 different areas, we can see how an electron and a positron can be located in the sphere or in the circle orbit, and you can have 4. Rather than 2 electrons, you actually have 2 electrons and 2 positrons within this model. And that provides a way of understanding how single atoms work in these Faraday cage-like systems of an aromatic ring, where there's only room for one atom. And so I've kind of had to look cosmologically, get a cosmological model that can understand dark energy and dark matter, understand inflation, understand how that decay system is actually responsible for generating positron electron pairs, and then look at the geometry of light within Einstein's structure, of rearranging that formula, apply that to a mathematical cross, and then seeing how I can apply that to hydrogen biology. Because when it comes to quantum tunneling and entanglement in biology, hydrogen is there's no other element that is small enough to tunnel and entangle. And so there's 3 quarks, right? The proton, 3 quarks, 1 electron, there's 4. And the neutron, 3 quarks, and the positron, there's 4. So this concept of 4 and the light geometry of electromagnetism can be applied directly to the geometry of hydrogen, single atom system, and quantum tunneling. And so I've looked at that as a way of understanding potentially how biology is using hydrogen foundationally to grow atoms in these aromatic ring systems, and how that's a storage of light, how that creates a time reversal symmetry in the atomic decay to release the light through a delay process that allows conscious integration. So the isotopes are working faster than the conscious mind. They're providing the imagery within in order for the neuron to communicate, right? They're receiving the light, which we're perceiving as the external physical world. Well, that's what we're taught in materialism in a reductionistic sense. When you go down to, well, the electron transition between the first layer of hydrogen, the Lyman line gives UV light, the second layer gives visible light, the third layer gives infrared light. So the electromagnetic spectrum is aligned beautifully with hydrogen biology and the orbital layers and the transitions that electrons are going through. So the model of dopamine with its amine NH3 plus, the hydrogen being the delivery of the light into the aromatic ring system of dopamine where that single atom resides to give the isotope. The isotope is timed, it decays, it releases. So that high energy expansion of the photon going bigger, 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 going from UV to visible to infrared, which is in a sense a redshift perspective of the expanded universe, right? So we're getting light expansion within us as part of the delivery of information in this isotope decay system that's happening, that's operating within us. So the model really allows you to internalize, I guess, the processes that are operating within the universe, to understand the physics that's happening within biology. And in doing so, it provides a way of exploring biology not from carbon and not from metabolic processes of carbon. I'm a biochemist. I know those metabolic processes, but it shifts our attention to hydrogen. It shifts it into physics. Quantum physics is too hard for me. I'm not clever enough to do quantum physics, so I've kind of bypassed the problem of uncertainty into a determined model through not interacting, to put the system at a point of equilibrium, the balance of opposites. And from that balance of opposite state, that's when isotope physics is undergoing its processes. So it's separate from the physics that you get in a system if you're interacting with it. And that's why we sleep at night. We sleep at night in order to get the conscious mind out of the way so that these atoms can come back to a stable state by decaying and releasing light. So the model...
So what you're really describing is the unconscious mind of the universe.
Yes, which is also our unconscious part of our mind, because we are, in a sense, created from the universe itself, right?
Yes, there is an interaction between the individual mind and the universal mind. Yeah.
So I'm providing a framework to understand the physics of the unconscious. Right.
Okay, that's fascinating. I think we've reached the end of our time. But we've also arrived at a conclusion which concisely explains the delicacies of your theory, and it is really a question of light and the singularity model coming together in a balance of opposites, what we philosophers might call a dialectic of opposites, to produce the unconscious mind. Yes. I mean, that's I'm extrapolating.
Well, if you think about where it's occurring outside of the neurological aspect of mind, so it's in that water-based milieu of the brain, right? It is in a sense the transfer of hydrogen from water through to the hydrogen on the amine and dopamine into the atom that's housed in the ring system. And so there's this food we eat that provides us with the hydrogen in our biology to produce ATP in water, so that the water generated within our bodies is quantumly competent. And this quantum coherent light being that humans are human being, Hu as in light, we are in essence utilizing this hydrogen as the foundational creation of our being through these systems that are functionally able to create atoms within us. So, when you start utilizing more light energy processes within your body and start conceptualizing and understanding what's actually going on at those levels, your perception, I guess, of reality shifts slightly, and you're able to explore more internally in those processes through this logical framework. So the framework itself provides the information of what's happening when it happens and why it happens, because of the timing of the isotope half-lives and the velocities that are coming because of the energies of them. And so it becomes very deterministic. And we have a conversation about free will at another stage, and
yes,
we still get to make a decision, right? Whether or not we believe it or not, or whether or not we want to explore more to try to see if there's a foundation here worth exploring. So let's leave it there, and our 30 minutes is up. And thank you very much, and we'll do another one.
Thank you.
Next week.
Yes. Look forward to it.
Brilliant.
Okay. Take care. Brilliant.
Thank you.
Okay.
Bye.